All right, guys, so today we are going to do 1.4C, more similar triangles notes. I'm on page 69 in your books, and let's just go ahead and get started. So it says here, triangle ABC is similar to triangles DEF, GHI, and JKL. The scale factors for the dilations that show triangle ABC is similar to each triangle are in the table. So if you look down here, we've got all of our scale factors right here. Okay, so ABC, the scale factor is 1 because it stayed the same, right? So we're going to multiply all of those side lengths by the scale factor to figure out what the side lengths of the other triangles are. So just like we did with dilations, with that first learning goal of the year, right, we're going to multiply the scale factor. It's always multiply. Because all of these scale factors, these first two are bigger than 1, we know that those triangles are going to be larger. And then for the last one here, this 1/2, since it's smaller than 1, remember if the scale factor is smaller than 1, it's actually going to make the shape smaller. Okay, so the first thing they're going to have us do here, it says down here in the directions here for number 1, find the side lengths of triangles DEF, GHI, and JKL. Record them in the first table. So that's what we're going to do. We're going to multiply each one of these side lengths by the scale factor. I'll zoom in so I can write nice and neat for you. For this first one, for DEF, we're multiplying everything by 2. That's what my scale factor is, right? So if I multiply 4 by 2, I get 8. If I multiply 5 by 2, I get 10. And 7 by 2 is 14. So there we go. There's triangle DEF. Next up is GHI. This time I'm multiplying by 3. So 4 times 3, because it's from the original ABC triangle. 4 times 3 is 12. 5 times 3 is 15. And 7 times 3 is 21. And then I'm on to my last one. My last one here, triangle JKL, and that one is scale factor of 1/2. So I'm going to go ahead and multiply everything by 1/2. 4 times 1/2 is 2, or half of 4 is 2. Half of 5 is 2.5, or 5/2. I'm going to write that as an improper fraction rather than a mixed number. And then 7 times 2, or 7 times 1/2 is 3.5, or 7/2. And again, I'm just going to leave that as an improper fraction rather than write it as a mixed number. Okay. Now, the next thing they want you to do here says, for all 4 triangles, find the quotient of the triangle side lengths assigned to you and record them in the second table. So we're not doing this as a partner activity. I'm just going to do this together with you. All right, so that quotient is when we take the long side and divide it by the short side. That's what we'll do for all of the first ones, and the long side measurements are all over here in this column. Okay, the last thing that we'll do, or the next thing, sorry, is the medium side, and then the last one is the short side. Medium side divided by the short side. So for this first one, for triangle DEF, well, here's the measurement of my long side for triangle DEF, and it wants the long side divided by the short side, right? So 14 divided by 8, and I really have to zoom in so that I can write that as nice as possible. Okay. For GHI, it is 21 divided by 12. Write that there. 21 divided by 12. And then for the last one, remember this is the triangle that got smaller, JKL, it's 7/2 divided by 2. So I'm going to have to write that off to the side here. 7/2 divided by 2. Well, what happens when I actually figure out what each one of those equal, I find it equals the same ratio or the same quotient as what we got for triangle ABC, which they had already done for us. And it should, right? If we know that similar shapes are proportional for their side lengths, then it should give us the same quotient for each one of those. All right, for the long side divided by the medium side, again, for triangle ABC, long side divided by medium side, that's just, zoom in so I can write this as nice as possible. That's just 7 over 5. For the next triangle, triangle DEF, it is 14 over 10. For the next one, triangle GHI, that is 21 divided by 15. So we're just taking that long side and dividing it by the medium side. And then for JKL, we have that 7 halves. I'm going to have to write this over here, 7 halves divided by, and that medium side was 5 halves. 5 halves. And what we find out when we actually do that division for each one of those is that same ratio again for each one of them. This time it's 1.4. The quotient, sorry, the same quotient for each one of them. And it's all 1.4. All right, for the last one, now I'm doing the medium side, so that's this column, divided by the short side, and that's this column. So for the triangle ABC, that is just 5, that is 5 divided by 4. For triangle DEF, that is 10 divided by 8. For triangle GHI, that is 15 divided by 12. And finally, for triangle JKL, that is 5 halves divided by 2. Now we should get the same quotient again for all of these, and when you actually do those divisions, you do see that it is 1 1/4 for each one of them. Okay, and so what do you notice about the quotients? They all stay the same. Okay, it doesn't matter which triangle you do this division with, that quotient is the same for each one of them. All right, on to the next page, on to page 70. If you look here, it says triangles ABC, EFD, and GHI are all similar. The side lengths of the triangles all have the same units. Find the unknown side lengths. So what's unique about this is we know if they're all similar, those quotients should be the same. So when I divide the longer side by the shorter side, that's going to be the same no matter which triangle I do that division on. So I'm going to look for what triangle has both side lengths. Okay, I can see right now, if they're all similar, the first triangle that pops out to me is this triangle ABC. And the reason it pops out to me is because it has these two side lengths. So you can see there both sides are the same, which means for this smaller triangle HI or GHI, that I know this side length is also 12/5. Okay, and I don't know for the larger triangle either one of those sides, but we'll find those out in a minute. So I know all of those side lengths have to give me that same quotient, right? When I divide, and that's what I'll start off with. I'll start off by dividing the longer side by the shorter side for this triangle, and then that same quotient will be for the other triangles as well. Okay, so I'll set that up, 12/5 divided by 6/5. Now from all the fraction work that we did earlier this year, we know that it's going to be 12/5 times 5/6. 12/5 times 5/6. Remember, keep flip change. 12 times 5 is 60. 5 times 6 is 30. And I end up getting a quotient of 2 for each one of these. So what's that telling us? That's telling us that this longer side of the triangle, let me erase this, this is starting to look kind of sloppy. This longer side of the triangle is twice as long as this shorter side. Okay, so now that I know that, this side of triangle ABC should be twice as long as this side. Well, what's half of 4? That gets me that side C right here is 2. That's the only number that could work, so that would give me the same ratio of 2, right? Now, if I try that, if I test it, I should get 4 divided by 2 equals that same ratio, and it does. That gives me that same quotient. Okay, so I've actually just figured out 2 of the side lengths. Earlier I found out that side H was 12/5. Let's go ahead and mark that down. And now all I have left is D and E. So over here on this big triangle, remember this long side should give me that same quotient when I divide it by the short side. So what could I divide by 5 to get an answer of 2? And we know that that's 10. And E is going to be the same, because for triangle ABC, those 2 longer sides have the same length. Okay. Your assignment goes on the next 2 pages, pages 71 and 72. Make sure you ask your teacher if you have any questions.